Classic 6. All right, follow video here. Continuing on the PH2 versus BT2 debate. So in the previous video, what I was doing is comparing batteries with the PH2 connector to the BT2 connector. And ultimately what I found was that there is a difference in favor of the BT2 for voltage, but it's pretty small. And it's small enough to where I think if you have either one of these connectors, there's not really a huge compelling reason to switch from one to the other, because I thought the performance was close enough. And I had speculated that the NewBeeDrone nitronectar gold connector, which is this one with the red casing, would be even better than the standard solid pin PH2, which you can see here. Because it's got a nice gold plating. So if you pull them apart, these pins are actually plated with like a 24 karat gold, and so that should give you better conduction. Also should get rid of the problems that some people report in terms of the connectors oxidizing and falling off, particularly if you're in humid environments. And so the last video Kelvin saw, and he said, hey, do you want to try some of these and test them out? I said, sure. So he sent over a pack of some of these nitronectar gold connectors, also some fresh NewBeeDrone nitronectar batteries. And I went ahead and I made Abomination 2. So this video is like, or this test is almost worth it, just showing you like these horrendous things I came up with. So what I wanted to do is I wanted to get the BT2 connector straight onto the same wire and as close as possible to the pins with the nitronectar gold connector, and I was able to do that. And so I had this connector soldered up to this quad. This is the same one I was doing before with the PH2 versus BT2 comparisons. But when I put this on, I was actually surprised that I was seeing a pretty big difference between the BT2 and the PH2, more so than so with the nitronectar gold one, I was seeing a bigger difference, a bigger gap between the voltage on the nitronectar versus the BT2 than I was with the regular solid pin connector. Or here's an intact one. So I thought that maybe I had like pulled some wire out or something, or compromised something with this little get up here. And then what I did is I said, well, okay, let me just go ahead and solder an unharmed nitronectar gold connector straight to the board. So I've got that soldered from this side, and I've got the BT2 connector soldered from the other side. You know, with the understanding these leads are going to be slightly different length, and hopefully, though, the pigtail isn't making any kind of big difference there. What is interesting is when I started flying these, is I kind of saw a similar story to what I did with this connector here, that I saw an ongoing gap between the gold connector and the solid pin. Basically, the solid pin, or the NewBeeDrone gold, was just not working as well as the solid pin. So what I would do is I would take a BT2 battery, a gold battery, or BT2 battery, and then a PH2 battery, and fly the PH2 on either the gold or the solid pin connector. I'd fly them for a minute and then hover and then check the voltage. Then I'd fly out to 2 minutes and land. I would check the ending voltage, recovery voltage, and how many mAh, you know, the quad estimate I used. And this top line, these couple lines are pretty representative of what I saw, where at 2 minutes on the BT2 connector, I was seeing like 3.72 volts at hover. On the gold connector, I was seeing 3.63. So that was a bigger difference that I was used to seeing, closer to like a 10th, you know, 0.1 volts. And then surprisingly, solid pin better than the gold pin, the NewBeeDrone gold nitronectar. So I was kind of seeing like 3.65, 3.67, and it was reproducible. It was pretty consistent. So like 3.75 versus 3.63 versus 3.68. And the trend, although kind of there's some variation in here, the overall trend, if you average these out, is pretty consistent. That what I was seeing is that the BT2 was about a tenth better than the gold, and about 0.3, 0.5 better than the solid pin, which got me really curious as to why. So the solid pin connectors I got good ones. Like I ordered them from like DigiKey or something like that. So these are legitimate, you know, like, I don't know if whatever legitimate means, but they're not like super cheap knockoff products. But, you know, if you look at the pin, if you pull these apart, see if I can show you this pin. This is the pin in the regular solid pin PH2. It's just like, I think it's like tin plated or whatever, versus the NewBeeDrone gold pin. And I thought, well, maybe, I don't know, maybe something was happening in terms of like how the interaction was here. So if I take just the gold pin and, you know, try and slide it into the connector, the amount of like resistance and kind of tightness on that fit, it feels fine on the NewBeeDrone gold connector. And it feels pretty similar to if I go ahead and insert the pin from the solid pin, the regular solid pin PH2, like the amount of resistance that takes, you know, that the tightness in there feels pretty similar between the two. So that to me is a little bit of mystery. You know, yes, on this pin, I think there's a little bit more material between where I'm soldering, where NewBeeDrone solders the wire. You can see there's a little bit extra pin length, where when I solder these onto the solid pin, I can get it pretty close. So, you know, you're basically going from the pin to the wire, maybe a little bit quicker, but I don't know. I don't get that. I don't understand why I'm seeing better performance out of what really on paper should be the inferior connector. So that's kind of strange to me. I did try this on two different NewBeeDrone nitro connectors, and I saw a similar pattern, so I think it's reproducible. And it's to me, it's a little bit disappointing. One, because I thought this like abomination of a quad would show something a little bit more interesting than that. I thought I was going to see the nitro connectors really going neck and neck with the BT2, and it wasn't what I saw. And it's also kind of a little disappointing because, you know, I kind of understand Kelvin's point. What he wants to do is see how far you can push the PH2 technology, like push it to the very limit of what you can get out of it, because that way it's still compatible with the old style connector, and you don't have to jump over to the BT2. But in this case, you know, for my testing, doing the best I could with nice new batteries, at least, you know, two different nitro connectors, I'm just seeing performance, you know, of the nitro connector just not doing as good as the regular solid pin, and now being what I consider a notable degree off of the BT2, where it's, you know, after just a minute of flying, it's a 1/10 off. Granted, these motors are sucking a lot of amps, or drawing a lot of amps. These are the Beta FPV 0702. They say they're like a 27,000 kV motor, but compared to the Happy models, I think that kV, either the Beta FPV is understating the kV, or Happy model is overstating their kV, because they're definitely punchier motors. Like, they draw more amps, but you also get more kick out of them. But that is a pretty like power demanding setup. But yeah, so after a minute though, you know, a 0.1 volts it's not like, I don't know, it's not make or break, but it's enough to where I think you can feel it. So always a little tough when I think, you know, NewBeeDrone was really gracious to send this stuff out, and it's always a little tough when like you get some, you know, product and some people interacting with you, and then, you know, it's kind of like, no, it didn't work as well as I would have liked to see. So that's what I have for this one. I'm not going to bore you with a ton of flying, because I think the summary, the results kind of like illustrate what you needed to know about it. But I am going to, you know, message Kelvin and just let him know what I saw, and, you know, see if they have any thoughts on it. But that's what I got out of this test. Until next time, cheers.